Now what do you mean by that? Polarization of wave. So first of all, definitely polarization of wave. So what we are going to see, what do you mean by first? Unpolarized light. So in case of unpolarized light, so light is having n number of components which are vibrating perpendicular to the direction of propagation. Yeah, so if it is vibrating, yeah, obviously you can say that. So this is nothing but one plane, yeah, in which it is n number of components which are vibrating. Yeah, and let's say this is the dot. Yeah, so this is along, let's say, which is into the plane in which it is propagating. Yeah, so there are various components of light which are just vibrating, yeah, in a plane, and that should be perpendicular to the direction of propagation. The same thing which I have shown over here, you can say that. So this is the plane, so which is there are consist of n number of your components, electric field components of that light or for that wave. So they are vibrating in a plane which is perpendicular to the direction of propagation. So that is what we can call it as a unpolarized light. So the next thing what we have to do, we have to make that light polarized. So in case of polarized light, you have to make sure there is only one component which is vibrating perpendicular to the direction of propagation. So initially I have just shown that few number of components which are just vibrating perpendicular to the direction of propagation. Yeah, but now you have to make some arrangement so that finally you will get there is only one component which is vibrating perpendicular to the direction of propagation. So that is nothing but called as a polarization of wave. Yeah, so in which you can say that, so the component of light should vibrate perpendicular to the direction of propagation. So that you can do with the help of definitely the instrument or with the help of device, that is a polarizer or that nickel prism. So there are different techniques that you can use for the polarization of your waves. Yeah, so obviously we are just going to reduce the intensity. We are just going to reduce the intensity for that wave in the case of your polarization of wave. When you're using the sunglasses, obviously the light which comes out of that sunglasses, it is nothing but a polarized light. It is nothing but that we can say the polarized light. The different glasses, again they are polarized, so only you can say that the certain components that which is able to pass through that your glass. So based on that, so there is a one very important law, that is a law of Malus, which states that, which is I is equals to I naught cos square theta. Yeah, so this is what we can call as a polarizer. So this is unpolarized light. So this unpolarized light, obviously it has to pass through this polarizer. So when it passes through that polarizer, the light get polarized. So it is having only one component, so which is vibrating, which is perpendicular to the direction of propagation. Then this is analyzer. So this is the axis of your polarizer, and you can change the axis of analyzer. So the angle between them we are going to call it as a theta. So if I make, say, let's theta is equals to 0, then in that case obviously I is equals to I naught. But if you make that theta is equals to 90 degree, then definitely the intensity of light which comes out of that analyzer is 0. So by just changing the orientation of analyzer, by just changing the value of that theta, you can change the intensity of light also. Yeah, so one polarizer that is used first of all to polarize the light, that is a why make sure that there is only one component perpendicular to the direction of propagation, and then again after that also you can change the intensity of that light. Yeah, so which is I is equals to I naught cos square theta. Yeah, so based on the value of theta, the intensity also gets changed. So that is what we can call is a law of Malus. So this is again the polarization by reflection. Yeah, so this is a polarization by reflection. The unpolarized light is going to strike on that glass slab. So this is the incident ray of light. So it is having, let's say I will consider the two components. One is nothing but this is, you can say that, which is moving perpendicular obviously in this direction, and one is moving in and out. Yeah, so this is up and down, in and out, both are perpendicular to the direction of propagation. Now when they strike it over here, when they strike on this glass slab, the light changes the direction and now it moves in this direction. Yeah, so now obviously the direction of propagation of light, so there is no component of vibration in the direction of propagation of light. It is having only the component which is perpendicular to the direction of propagation. So definitely you can say that after reflection it doesn't have the component which is along the same direction. So this component now will get vanished. It has been absorbed by that light. So there is only one component. So this component which exists over here, obviously part of the light will get reflected and part of the light will get refracted. So this condition you will get whenever there is an angle between this reflected, yeah, so this is nothing but the reflected and this refracted, it has to be 90 degree. Yeah, so this angle has to be 90 degree. So again what we can say over here, so let's say this is called as the angle of polarization. So this is also IP, this is 90 and this is R. So how we can say that then? So this IP plus 90 plus R, which is equals to 180 degree. So then this IP plus R, which is equals to 90, then you can write it down that mu is equals to sine IP upon sine R. Then this is sine IP sine R, you can write it down, that is a 90 minus IP. So this one you can write it down, that is a mu, this is your sine IP, then again sine of 90 minus IP, which is what you can say that, which is your cos IP, then this mu is equals to tan IP. So this refractive index is nothing but tan of your angle of polarization. Yeah, so when a ray of light is going to incident at that your glass slab at an angle of your polarization, the reflected light is completely a plane polarized light. So that is what we can say about the Brewster's law. Yeah, so this is the condition. One more condition, obviously the angle between reflected and refracted ray has to be 90 degree. So under that condition you can say that, so the reflected light is completely plane polarized light. So where you can say that obviously in the same thing which I have shown over here, so the two components, obviously it is not possible. So only one component which is perpendicular to this direction of propagation. So this is only possible. So out of that, so this is the only thing which you have to show over there. Yeah, so that is what we can call as a Brewster's law, where I'm just saying that, so this is obviously after reflection you can't show this your in and out components, so you have to show only this component. Yeah, so just even though I have just shown that, but obviously just to make sure, so it is obviously again I can say, so after reflection, so it is not possible for that component, and that is how we can show that. So the reflected light is nothing but again it is a completely plane polarized. So this one you can explain with the help of this diagram also.